So I'll run you through the testing right now. Many of you have just gone through this. So there's two broadband categories of testing. There's short-term testing, which is defined as tests less than 90 days. And there's long-term testing, which is defined as 91 to 365 days. So the devices that you used are long-term testing devices, and that's what Health Canada advocates today. They've had that position for some time. There's been some technological advancements since then in detection technology that there may be a day where they'll soften their position and welcome short-term testing as well. But I'll walk you through both scenarios right now. So these devices here, this is the device that you guys used to test. This is called an alpha tracker. And as I said earlier, it's a 91 to 365 day test. So the way this test works, you guys open the package, the test begins. The air diffuses into this. Inside the middle of this chamber, there's a small plastic film. And it's a highly specialized plastic. It's called CR39. It's manufactured in one plant in the world, in Manchester in the UK. So as the air diffuses in, those alpha particles that I talked about earlier, as they release their energy, they strike that plastic, and CR39's got a unique principle, unique component of it, that lets the alpha particle etch it. So when you send it back to the lab, what we're going to do is open this device, take that CR39 out, and we're going to read it under a microscope. And that's going to tell us what the average radon exposure was over the period. You've told us the period of time you tested when you did your online registration. So we scan this device in the lab. We know whose device we have, and it gives us a large number. And then we do a calculation based on the test length. And that tells us what the average radon level was in your home. And that's important to remember. It's the average level over the period of time. So the device beside it, the larger device, this is new technology. This just got approval last year. Same technology, but it's a 10 to 31 day test. So essentially it's a larger air chamber and a larger piece of CR39. So we get a lot more reads and a lot more volume of air in a shorter period of time. And in the independent testing that we did to get these certified, the difference between these has yet to exceed 8%. So the accuracy of this is plus or minus 12%. So it's not, it sounds like it's a lot, but interestingly enough, the nuclear power industry works to a plus or minus 25% differential. So these are highly accurate, and there's not a great difference between the two. So, you know, when people call the office and they're in a real panic, they've been to the oncologist, they've got bad news, they want to test their house, they're in a panic to find out, we sell them this now. We get a 30-day result. We try and get them to buy both, so we start the 91 day, but we pull this at 30, and we got a snapshot of what we're going to be looking at the end of it there. So this next device is very simply a radon alarm. It looks like a smoke detector or a CO2 detector for a reason. We want it to look like that. It's battery operated. Change the batteries once a year. The difference being that this measures radon peaks. So when it detects a peak of 150 becquerels, not 200, 150, it sounds an audible and visual alarm. It's got a reset button on it, just like your smoke detector, so you can make it stop screaming. But at least it gives you a warning that there's a problem. You need to investigate further. It allows you to open the windows, get some airflow going through the house or the building. Or we sell it a lot for post-mitigation systems. Somebody's come in and installed a system to mitigate the home or building. You want to know if it's failing, right? So this is a great detection device for that. So these last two pieces here, this is a lab-grade piece of radon detection equipment. It's the most sensitive piece of equipment in the world. It's plus or minus 4%. It's made by a small company in Ottawa called Pylon Industries. And basically it uses a Lucas cell technology. So this cell here, this is an air grab sample cell. So we can send this out to the field under 28 pounds of vacuum pressure. We can go into a large building or a home. If we suspect that maybe the sump pit is the source of radon in a house, we'd go down to the sump pit, we'd put a swage lock pin in it, and we'd grab an air sample of that. 3.5 hours later, we can read this cell. It uses a photocatalyst technology, so inside this cell, the alpha particles strike and they leave an etching on it, and we read it under photocell, and it gives us the reading. So this same machine, you can see the Lucas cell that looks a little different that's on the machine right now. That's a continuous cell. So this is an active cell, and that's a passive cell. We can take that machine, set it up in a building, and we can program it to do a radon test every hour. So we can chart what's going on in a building. And in large commercial buildings, we need to do that sometimes. We need to understand where the source of radon is so we can come up with a mitigation plan. The last piece here that looks like something somebody made in their garage is that's a device for testing radon in water. So basically what happens is the water sample is inserted in here. This Lucas cell is actually in the background there, you can see it, and it's under the 28 pounds of vacuum pressure. We aerate the water and it releases the radon, and we capture the radon it releases in here. And that allows us to determine the concentration of radon in the water. So WHO statement, well-tested, durable, and cost-effective methods exist for preventing radon in new houses and reducing radon in existing dwellings. And that's an important statement for some of you, because some of you will have high results.